So chapter 11 is further topics of algebra. So we're going to talk about sequences and series today. All right? So an infinite sequence basically is a function whose domain is the set of positive integers. So no decimal points in the domain. So you have the first term, the second term, the third term, the fourth term. So the subscript tells you what term you are. The A sub 1 would be the value of the first term, and so on. Okay? A sub n is the general form of the sequence. So when you go to write the equation, instead of y's and x's, we use A sub n and n. So some of these are very, very easy. So if I want to write the first four terms of this sequence, A sub 1, bless you, is negative 2 to the first power, which is this negative 2. Easy enough. A sub 2, the second term, is negative 2 to the second power, which is negative 4. Now notice, I did not square the negative. It's not in parentheses. So when I'm looking at this formula, the power is only to the 2. It's not including the negative. If I wrote it that way, it'd be a different situation. Okay, so understand. A sub 3 is negative 2 to the third. And A sub 4 is negative 2 to the fourth. So, not hard. So negative 2, negative 4, negative 8, negative 16, so on and so on and so on would be the terms. In the second example, you got a little bit more going on. So B sub 1, the first term is negative 1 to the first over 1 squared. Well, a negative to the first power is an odd power, so the negative is going to stay. So that just equals negative 1. If I have negative 1 squared over 2 squared, I get a positive 1 over 4. Third term is negative 1 to the third over 3 squared. So negative 1 to the third, that negative is going to stay. 1/9. So finding the terms is just simply plugging in the n value and evaluating. So you're plugging in your domain, 1, 2, 3, 4, and so on.
It must be positive when they're squared.
Yes, but the top is a negative 1 to the third. So that's a negative.
4 and 16.
Okay? So in this formula, this does not equal, it's not the same thing as this. So if it's in parentheses, I'd be squaring that negative. This negative is not in parentheses. So basically, they're saying negative 2 to the n, if you think of it separately like that. The negative is not being squared. Only the 2. Okay? Does that make sense? Only the 2 is being squared up there. Or to the fourth power, whatever. All right. Assume the general rule. We want to find, we're starting with first power, or the first term. So we want to find the equation. So the easiest way I know to do this is go ahead and write your domain values and try and figure out what happened to those to get you your range. Do you see anything? Notice anything about the numbers?
Square.
They're squares. So it's just n squared. Right? What if, I'm just saying what if, let's get rid of this guy. What if I did that? You're still squares, right? But is it n squared? Or is it n plus 1 squared? Because we shifted over 1, right? So this is 1 plus 1 squared is 4. 2 plus 1 squared is 9. 3 plus 1 squared is, right? So just kind of pay attention. They could shift things. So they are squares. but they might be something different. All right. I always look at the sequence. Is it a sequence that I can recognize? You see the pattern. Do you see that it's increasing by 3? So last year you might have heard of that and talked about it being an arithmetic sequence because we're adding by 3s. So arithmetic sequences in linear functions are connected. So we have a constant increase of 3. So that means that's my slope. And then you got to figure out, what do I do with the 3n to get down to the next number? So 3n, 3 times 1 is 3. What do I do to get it to a 1? Minus 2. Does that work for every term? Let's go over here. 3 times 4 is 12, minus 2 is, that's the general form. So when you see that constant increase or constant decrease, adding or subtracting by a number, that's going to multiply to n and then figure out the other part. This one's a tricky one. It just keeps bouncing back between 2 and negative 2 and 2 and negative 2. If you have it something alternating like that, positive, negative, it's got to be multiplying to a negative 1 to some power. That bounces it back and forth, kind of like we did over here. Right? This bounces positive, negative. And since my number's not changing, it's going to be a 2. Now, I want you to think about it. Does that work? Why doesn't it work? 2 times negative 1 to the first power would be negative 2. So I needed to start with a positive. So I can just fix that. Let's put a plus 1 here. Think about it. 2 times negative 1 squared. Negative 1 squared is positive 1, yes? Times 2 is positive 2. If I do 2 times negative 1 to the third, it would stay at negative 1. Times 2 is negative 1, or negative 2. So that would bounce back and forth. Okay? So if the negative is in the first term, it's just going to be an n exponent here. If the negative starts on the second term, it alternates. It's got to be n plus 1. Okay, what about this guy? Do you see this pattern on the bottom here? So my denominator is got to be n. And the tops are, how is the top related to n? N minus 1. And we also have alternating, right? Do I want n or n plus 1 here?
N plus 1.
N plus 1. Because the first term is positive. So it has to be an even for the first term. All right? Good? You guys try those. See how you do. You really want to put it into, what pattern do you see based on 1, 2, 3, 4. Okay. All right. So, recursive formulas. Those were considered explicit formulas because they're just an equation. Recursive formulas require that you have 1 or 2 or more terms given to you. They have to give you a starting spot and then a rule with which to deal with those starting terms. So a very, very famous guy, Fibonacci, developed the Fibonacci sequence. Okay? So the first term, they call it a sub 0, but still the first term is 1. The second term was also 1. And then the rule is, so think of it, if this says a sub k, let's put a number in there. If this is the 8th term, this is k, that means the 6th term plus the 7th term. That means the 2 previous terms. That's what that means. The subscripts are telling you what term you're on. Okay? So how this term or this sequence works is my first term is 1, my second term is 1. I'm going to add those. So 1 plus 1 is 2. The third term is going to be 1 plus 2, these two added together, which gives me 3. Then it's going to be 2 plus 3. You're just taking the previous two terms and doing what it told you to do with them. 3 plus 5 is 8. 5 plus 8 is 13. And you just keep doing that process. 8 plus 13 is 21. 13 plus 21 is, and you can keep going on and on and on. This sequence is actually seen in nature. Look like the petals of a flower. You'll have one row that has 5, and then the next row will have 8, and the next row will have. It's kind of cool. But it's seen in nature. But that's a recursive formula, where they give you a starting point, and then they tell you to do something with it, okay? Using the previous terms. So in this case, our starting point's -3. And then this is the rule. 2 times the previous answer plus 5. So 2 times -3 is -6 plus 5 is -1. Next term is going to be 2 times the previous answer plus 5. So 2 times -1 is -2 plus 5 is 3. And you just keep doing that. You keep throwing the answer back in. 11. There's the first 5 terms. And you could do that forever and ever and ever. So, with recursive, you can actually see what's going on. With explicit, you can find the 100th term without finding all the first 99 terms. So there's benefits for both of them. All right? Easy enough. Okay, I'm going to get this done. Use the graphing calculator to find the first 10 terms of the following sequence. So we're going to bring our calculators up. You're going to go to y equals, and you're going to type this in, but instead of an n, you're going to use an x. So it's going to be x times 1 plus, minus 1 divided by x. All right, so you have to go to your table, but first let's do the table setup. So second table setup, we want to start at 1, and we're going to go by 1 because we're talking integers only. And then just look at your table. There's your first 11 terms, actually. Right? They seem a little bit easier than what the formula looks like. Doesn't the formula look complicated? If I distributed this n, wouldn't that just be n minus 1? Go to y equals. Type in the equation. You got that? And then I want to go to table setup, which is second window. Second window. Maybe. You want to start at 1 and go by 1s. So 1, 1. And then hit second graph, which is your window or table. Sorry, second table. Get it? All right. So it's a really easy sequence, actually. It's just 10 minus 1. But it looks more complicated because we didn't distribute it. All right. Here we go. Factorials. Somehow I missed a slide. There you are. Factorials. So a number to the explanation point. It does not mean 5 like that. You know what I mean? It's not exciting 5. It's not an explanation like that. Okay? It just means you're going to take that number and multiply by every integer below it till you get down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. 125 or 120. Okay? So 8 factorial over 6 factorial, think about it. It's 8 times 7 times 6 times da-da-da-da-da. The 6 times all the way down to 1 is going to cancel out with this 6 factorial that's in the denominator. So you just cancel it and you get 56. All right? You have to be able to do it this way by hand. Because, for instance, Cameron's got his calculator. Cameron? What's 135 factorial divided by 133 factorial? With your calculator. Oh, let's use the factorial button. So 135, do that little alpha window button you got. 9's factorial. Did it work? Go alpha window and then you hit number 9.
It's 18,000.
What's the Q on?
Who got an overflow? Cameron's calculator's a different one. It might be a little bit bigger. We get a big number? Something that we can't do?
I gotta quit.
Overflow. All right? So if I give you a big enough number, it will freak your calculator out and it won't be able to do it. So, what you can do, yeah, guys, the factorial button is, like I said, there's a shortcut here. Alpha window, where all those little guys you were doing before, your base and everything, log base, it's number 9. Or you can go to math and go over to probability, and it's number 4. All right, but if we do it by hand, this is 135 times 134 times, as soon as you get to the denominator, you can stop and that cancels. And then you can take 135 times 134, your calculator will be fine. We couldn't solve the factorial because it's too much for it to compute. But it can do 135 times 134, yes? 18,000 and what'd you say? 90. Okay. So Cam's calculator has a little bit higher level of tolerance. But if I tell them 576 factorial over 573 factorial, how many of those go? You try.
Sometimes we're 1 0.
Why can the calculator do that, but it can't do the other one?
It's because it has to do all those calculations. So it's doing 135 times all the way down to 1. It's not doing the shortcut. It's not doing the reduce first. Okay? It's a no-go. So try this guy. Do it without your calculator. I just want to know what integers are you going to multiply by?
13 times 4.
15 times 14 times 13 times 12 factorial. So as soon as you get to the denominator, you're done. You're going to cross them out. That would be your answer. Okay, with the calculator, you can multiply together. But let's just skip that part. How about this guy? N plus 1 times, what's 1 below that? If I take 1 away from that, what do I get? N times, take 1 away from that, n minus 1. We don't know what n is, guys. So if I had n plus 1, and I take 1 away, I'm at n. And if I take 1 away from that, I'm at n minus 1. If I take another 1 away, I'm at n minus 2, and so on, right? But I only have to go down to n minus 1, because that's what's on the bottom. And we cancel. And then if they wanted you to simplify that, you would go ahead and distribute. Right? Okay, this guy here, we're starting with n. 1 below that is n minus 1. 1 below that is n minus
2.
1 below that is n minus
3.
Boom. Done. Calculator. Right? And then I can distribute. And that's why it was simplified to. So nothing crazy. We ready? Sigma notation. So sigma, not just for frat boys. It means to add up. Summation. Okay? Summation. So your starting number, called your lower limit, is telling you what term you're going to start with. It doesn't have to be a 1. It can be a 6. The ending number is your upper limit. It's what term you're ending with. It might be, 1 to 7 or 4 to 10 or whatever. And then you have your function here that's going to have the I or the N or whatever in there. Whatever your sequence is. Sometimes they use I, sometimes they use N's. Okay? So you're just adding up the terms of the sequence. So you have to find the terms first by plugging in the index numbers and then add them up. That's what the sigma means. Summation notation. Okay? Sorry, I forgot. Don't yell at me. All right, so this is an easy one. It's just I. So the first term is 1, the second term is 2, 3, 4. What am I going up to? Then you just add them up, and you're done. Easy breezy. The second one, what number am I starting with? 4. So it's going to be 2 times 4 squared minus 1 plus 2 times 5 squared minus 1 plus 2 times 6 squared minus 1 plus 2 times 7 squared minus 1. So you're just going to plug in the numbers 4 through 7. So that's 31 plus 49 plus 71 plus 97. And you're adding those all up. Those are the terms of the sequence. I get 248. Okay. We're going 0 to 4. So 2 to the 0 over 0 factorial, which, by the way, if you saw on the other screen, 0 factorial has to be 1 for things like this, okay? Plus 2 to the first over 1 factorial plus 2 to the second over 2 factorial, 2 to the third over 3 factorial, okay? So 2 to the 0 is 1, divided by 1 is 1, plus 2 divided by 1 factorial is 2, plus 4 divided by 2 is also 2, plus 8 divided by 1 times 2 times 3 is 6, 8 divided by 6 is 4/3, plus 16 over 24 is
4 squared.
16 over 24 is 2/3.
Yeah.
Okay. So if you add them all, you get 7. All right. Now you can do this with your calculator. So again, there's times you're going to be able to use your calculator, times you won't. Let's pretend you can. So again, in the little shortcut menu, the alpha window menu, you see it says summation. Number 2. And you're just going to fill it in using X instead of whatever. X equals, let's do this one. 1, go up to 9, fill in the little boxes, and then the function is just X. It'll add it for you. Okay? Alpha window, summation, X equals 4 to 7 is my upper limit, and then it's 2x squared minus 1. Easy breezy? Okay. Write in summation notation. What time's the bell ring? 51?
51.
All right. So what is going on here? We've got to figure out the pattern. We have to figure out the function. So it's going to do this. What's the function? I see that it's going up by 2. So it's 2i. I'm going to put my little things up here.
2i plus 1. Wait.
2 times 1 plus 1, right? Does that work?
Yeah.
Yeah. Hard part. What's my upper limit? I know I'm starting at the first term. What term am I ending at? So what you have to do is take your function that you just wrote, set it equal to 21. X equals 10. So the last value, what this equals, so this is going to be a 10. Does that make sense? Okay. What in the heck's going on here? 1. What's your pattern?
Times, wait. N times 2 multiplied -1.
Negative 1 raised to the n
Plus 1.
plus 1 pattern, right? All right. We already have 1, 2, 3, 4, 5, 6, 7. We already have all terms. We don't have any dots. Right? You guys can figure out the last one? Yeah, we'll do it. We'll do it since we're here. So the sequence is
1.
n over n plus 1. And we're starting at x equal or I equals 2, 23. Okay, you have a math Excel. It's due on the 14th.
The cell phone?
We're gonna work it, Mom? Did you finish?